Chapter 2 talks about growth and development. We're going to get into details about the physical patterns and the physical growth and development of our young children, their skeletal maturity, their muscular development, how overweight children are affected by PE. We're even going to talk about how to help our students be successful in physical activity with motivation and feedback and the actual proper progression to ensure success. And then we're going to finish off with some safety guidelines as far as for training, distance training, fitness training, resistance training. Hopefully, after we finish this chapter, you will be able to answer this question on why understanding the way in which a child grows and develops is essential for their success, and you'll learn not to treat all the different body physiques the same. Let's look at the physical growth and development on page 22. I want you to know the growth patterns of children are generally controlled by their genetic makeup. The parents, the grandparents, how genetically athletic they are, or musically inclined, or different attributes. So the unhealthy environments can have a negative effect on the proper growth and development, but in this section we're going to look at the maturation patterns that are most common amongst our students. So, timing is everything. I want you to know, although all children follow a similar general growth pattern that we're going to talk about, each child's timing is unique. And you can see that I've seen for the different nationalities, Germans, Spanish, the different nationalities. Some people mature later than others. It all depends on their nationality or their genetics. In this diagram, figure 2.1 on page 22, if you know anything about a velocity curve, where is a drastic change? Notice birth would be on the far left because the age is at the bottom. So birth would be the apex, the point where the horizontal and vertical line meet. So, and then you have 1-year-old, 2-year-old on to 19 years old. And then on the left side, you see the height gain. So notice where the big change is, the most change, from birth till about 5 years old. This is what you need to realize. There's such a huge, rapid growth. And you need to know this as a person, as a mom, as a parent, as a teacher, or a father. Children go through a rapid growth period from birth to age 5. Look at your own children or nieces and nephews, or be observant of anybody. From birth to 5, they change so much. If you don't see them in a week, it's like, oh my goodness, they've changed so much. And it's like, oh wow. And then, or if you haven't seen them in a year, it's huge. It makes, they just grow so fast. So the next slide will have all the important facts, but here is where they show that drastic growth from birth to age 5. Then if you notice, the girls peak are before the boys, and this is common too. If you have a set of twins like I have in my family, they're a boy and a girl, the girl grew taller sooner, but then the boy caught up later and now is taller than her. As teachers and parents, we should regularly monitor the children to see if they are maturing normally. One way was the velocity curve that I just showed you on the previous slide, and showing how much a child can be expected to grow from year to year. So I want you to know, children go through a rapid growth period from birth to age 5. That's what I was talking to you about on the previous slide. From age 6 to the onset of adolescence, it slows down. So I want you to know, because the growth rate slows down during the elementary school years, okay, from 6 years old to adolescence, which is elementary, around kindergarten or so until the fifth grade. During this time when the growth rate has slowed down, this time is an excellent window for children to learn motor skills. Excellent window to learn motor skills. And that's why I cringe so much when elementary schools do not have any type of PE. This is the best time to teach them motor skills, kicking, throwing, catching, all kinds of things. But they don't have PE to be shown. And then when they are forced to take PE in the middle school age group, 6th, 7th, and 8th grade, when puberty kicks in, embarrassment kicks in, and they don't know how to do it because some are not exposed to it. They don't have parents or neighbors or city league to show them how to do it. And so then they get the don't wants. So this is a perfect reason why we need to have elementary PE, because their growth rate slows down. When they're growing, they're clumsy, awkward, off balance, tend to fall easily. But whenever they're not in that big growth spurt, that's the optimum time to teach them motor skills. So during adolescence, children grow rapidly until adulthood. So I want you to know, in the elementary school, boys are generally taller and heavier. The girls, they're going to reach their adolescent spurt first, like we said in the previous slide. They're going to grow taller and heavier in about the 6th and 7th grade. And this growth spurt is likely because they're reaching puberty earlier. But I want you to know, research suggests that in part, the increased rate of childhood obesity, specifically in girls, may lead to the early onset of puberty in girls. That's something to realize. We need to keep these kids active. We know boys quickly catch up and then they grow taller and larger. What I also want you to realize that's important, children are not little adults. Their proportions are so much different compared to those of adults. For instance, on the next slide, you're going to see that the head makes up 1/4 of the total length or height of the baby at birth, compared to 1/6 at age 6. So, think of it. Your head. Remember little infants, how big their head is when they're born? But then in the next 5, 6 years, in proportion to the rest of their body, the head is only 1/6 the size of it. So I want you to know, because these K through 2 students have short legs in relation to their upper body. Remember the upper body, the head bigger? We call them top heavy. And they fall more easily than adults do. So K through 2 children, they're not clumsy, they're just top heavy. Their head is bigger, and you'll see on the next slide exactly what I'm talking about. So as you see here, look at the child at birth. And notice there's 1, 2, 3, 4, 5, 6, 7, 8 sections, okay, horizontally. Well, notice the head of a baby, of an infant, takes up 2 of those sections. So that's 1/4 of the baby's total body length. That's big. That's a lot. But then look, as they're 2 years old and then 6 years old, but the 2-year-old, it's almost still 1/4, okay? 6 years old. Then look at a 15-year-old and a 25-year-old. The head is maybe 1/8, not a little bit more than 1/8 the size. So if you know anything about fractions and proportions, you can see why when they're little, from the kindergarten through 2nd graders, why they may fall a little easy. Their heads are bigger. They do not have a PowerPoint slide for the actual figure 2.2 and figure 2.3, which shows females and males, their stature for their age and weight and what percentile do they fall into. If any of you have taken your child age 2 to up to 20 or 18 to a doctor, they take their age and then they all take their weight and see what percentile they fall into between 5 and 95, or their stature, how tall they are. So if you would want to play with that and see, which is what I normally do in class, I pick a student who has a child that's young, and once we know their age and then their weight, we can see what percentile they fall into, as well as how tall they are. We can see what percentile they fall into. And basically what you're saying with percentile, you take 100 kids the same age, and let's say if they fall into the 75th percentile for their weight, then 74 kids would weigh less compared to he or she's in the 75th percentile compared to other children, 100 children, boys or girls. But on page 25, let's talk about body physique. So a child's physique, if you want the official term, is called somatotype. And this is going to affect their motor performance, their quality in being able to move, and athletic versus maybe non-athletic. So I want you to know these three major body physiques. The first one we talk about is mesomorph. A mesomorphic body type, I want you to know, they perform the best in activities that require strength, speed, and agility. So, most team sports. A mesomorph is a person who we label muscles. They have a lot of muscles on their body. An ectomorph, I want you to know, is extremely thin. They have minimal muscle development, and they are characterized by calling them skinny. Keep your hard C-K sound together. Ectomorph, skinny, that might help you to remember and how to differentiate between the three. And then for mesomorph, as I just got through talking about, M for muscle, mesomorph, that might help you to remember. Your ectomorphs, they require strength and power, but they do really well in aerobic endurance activities like your mile run, your cross country, track and field, jogging. And if you notice, those people who run a mile, 2 miles, 5 miles, they're not skinny. They're not fat, rather. And I hate to use the F word. They're skinny because they have burned off a lot of calories and they have elevated their heart rate a lot. The endomorph is the last physique somatotype I want you to know about. The endomorphs are soft and round. They're excessively protruding abdomen. I like to say they have a lot of insulation. So the endomorphs are the ones who have trouble with aerobic and anaerobic skill-oriented activities. So I want you to know the overweight children are at a disadvantage in all phases of physical performance. So this is going to affect what you're going to require the endomorphs to do compared to the ectomorphs or compared to the mesomorphs. This is so important that you understand. We can't expect an endomorph to do 10 push-ups like we can expect an ectomorph to do 10 push-ups. An endomorph is picking up all of his or her body weight. And an ectomorph is picking up all of his or her body weight, which is a lot less. So you need to understand this basic concept to be able to apply it. If you're a city league coach or you coach your little children or you have them run so much to warm up or whatever it may be, we can't expect them to do as much because they're at a severe disadvantage. Skeletal maturity. You need to understand and you need to know for tests as far as for just in general, the physical maturity of a child, of a student, greatly affects his or her performance in PE. Now, what are we talking about when we talk about maturity? I want you to know maturity is usually measured by comparing the chronological age. Well, you need to understand that chronological age is the days, months, years. How old are you? Okay, that's chronological age. So we compare, for maturity wise, we compare their chronological age with their skeletal age. Now, what do we mean by skeletal age? Well, the hardening of the bones in the centers of the bone shafts, that's called ossification. At the end of the bone, in the middle of the bone, at the end of the bones is where your growth plates are. And if a child gets an X-ray for some reason, a young child, the doctor can say, "Oh, he or she's not finished growing, or has a lot because of that growth plate." They can tell the hardening of the bones. So I want you to know the rate of ossification accurately indicates a child's skeletal age. So the skeletal age is a true measure of their maturity. And like I said, the X-ray of the wrist bones would tell you if a child breaks their arm, and they can look at the X-ray of the wrist bones and tell if the child is finished maturing, already matured, fast mature, or if they're slow mature and still have some growing to go. So I want you to know a child whose chronological age, how old they are, how many years, how old they are, if it exceeds their skeletal age, then they're said to be a slow mature or a late mature. So you need to understand that. So if their bones have calcified, if they have no more growth plate, and their chronological age, they're older. Or I take it back. If they have not, if the bones and stuff have not classified yet, they still have some room to grow, then they're considered a late mature or a slow mature. So I want you to know, if we look at a typical classroom of third graders, who are normally all about 8 years old chronologically, we need to realize that there is a 5 to 6 year variance in the actual maturity of these students. So even though their chronological age is 8 years old, maturity-wise, especially in PE, you're dealing with 5-year-olds to 11-year-olds. And that's why those that are more mature, the 11-year-old, they're more mature, they are going to get it quicker. And the 5-year-old, the ones that are acting like 5-year-old maturity level, even though they're eight years old, they're not going to get it. They're going to struggle. So that's a very important concept that I need you to understand about children. And look at in this picture here, we have ectomorphs, like the third little girl, the second and third little girl. Okay, we have our mesomorphs, where some have more muscles on them. And then look at our endomorphs, the last two in the picture to the far right. They're all the same age chronologically, but look at the height is another thing. So you need to understand this. Also on page 26, they talk about the more mature student may have a distinct advantage. Okay, that's what I was saying. And they also talk about the children of both sexes who mature early are generally heavier and taller for their age compared to the late mature or the average mature. These overweight children, the endomorphs, are often more mature than the normal weight children. So I want you to know, overweight children also carry a greater percentage of body weight as fat tissue, which makes them less efficient and decreasing their motor performance because they have that extra body fat, that extra insulation, I call it. They're less efficient, and it also decreases their motor performance. Now, there'll be a heck of a lineman if it's a boy, okay? But in the physical activities that they're required to do in PE, it's harder for them to do. So, as a teacher, as a physical education teacher, if you take your students out to play, you need to ask your students. Some teachers often ask their students to learn at the same rate, regardless of the maturation level, and that's just not good because we have faster rates of maturing, slower rates of maturing. They do not mature at the same rate. So, what does that mean? I want you to know we need to offer a wide spectrum of developmentally appropriate activities so that we can help ensure that the children will succeed regardless of their maturity. Regardless of their maturity. So a wide spectrum of activities because we have endomorphs, mesomorphs, and ectomorphs. So if we'd be in a classroom setting, these two would be some great discussion questions. Hopefully you've learned the answer to these, why it's important to understand the skeletal age can vary greatly with the same classroom. The 5 to 6 year variance in skeletal age, maturity level, the actual maturity level of the students. And how can it hurt them with the maturation levels so different in the elementary years? Now, once we get older, well, high school, there's still a little difference, but once you get out of school, there's no difference. But in elementary, there's a huge difference. Let's look at the muscular development and strength of our children. In the elementary school years, your muscular strength increases linearly with their chronological age. What does that mean? Basically, we're saying as they age, their strength increases, okay? But what I want you to know, when differences in the strength between the sexes are adjusted for height, there's no difference in lower body strength for 7 to 17-year-olds. So what are we talking about here? Like it says on the PowerPoint slide, the lower body strength, there's no difference, meaning girls can run just as fast as boys, okay, in the lower body strength when the height and weight is adjusted, okay? But the upper body, that's where we find the boys are much more stronger in the upper extremities. If you were in school and you had to do the pull-ups, from 9th to 12th grade, the boys are expected to do more pull-ups and the girls are expected to do maybe 1 or 2 by the time they become seniors. Because the boys' upper body strength is much greater as we get older. So I want you to know, in activities demanding arm or trunk strength, the boys definitely have an advantage, even if they are similar to girls in height and mass. So upper body strength, the guys are stronger. Genetically, I want you to know the muscle fibers are genetically determined, the number of muscle fibers. So again, your parents, grandparents, aunts, uncles, so forth, that is genetically determined, the number of muscle fibers. So let's get into this. What are they talking about? Some people have more, I like to give the analogy of like uncooked spaghetti that you might have in those plastic containers or in the bag you bought at the store, okay? Some people have, like each one of those uncooked spaghetti noodles. You can look at that as muscle fibers. So the number of muscle fibers within the muscle, within each one of our muscles, due to your genetics, some people may have more muscle fibers and some people may have less. So what happens whenever we work those muscles? Your muscles become larger when the size of each muscle fiber increases. So the size of the muscles is determined first by the number of fibers and then by the size of each fiber within the muscle. So I don't know if you knew that, but that's genetics. So I want you to know the difference between slow twitch and fast twitch. Most people possess a 50-50 split. Most people have 50% fast twitch, 50% slow twitch. What does that mean? Fast contracting. Like when you take a step and then your foot comes off the ground for the next leg to go forward. When it contracts, when your foot moves closer to your buttocks, that's contracting. And some people have that's some are fast in that contraction, some are slower. So the percentage of fast versus slow contracting fibers varies from muscle to muscle, and it also varies amongst us individuals, as we just said, due to genetics. I want you to know most people have this 50 to 50 split, but you have a small percentage of people who have a ratio of 60-40 either way. They might have 60% slow twitch, 40% fast twitch, which would be those, as you see here on the slide, they slowly contract, fatigue resistant. But you know what? Who is that good for? Those who do aerobic activities like the mile run, they can go longer. Whereas, and for longer distances compared to those who might have 60% fast twitch fibers, which quickly contract, but they rapidly fatigue. So explosive movements that demand speed and power, like your short distances, your 100-meter run, your 200-meter run, things of this nature, those are the people who have possibly the 60% fast twitch fibers. So on page 28, they talk about what's the significance in this variation in the ratio. As I just got through saying, the slow twitch is well suited for the endurance activities. So I want you to know that. What are the slow twitch fibers good for? Your endurance activities, your aerobic activities, the mile run. Your fast twitch fibers are more suitable or suited for explosive movements. The long jump, if you've done any track, or the short distance running. But what you need to understand in relation to the elementary kids, surprisingly, our elementary kids who do best in activities requiring fast twitch fibers also do good in distance running. So what is that inferring? Well, the actual specialization into fast twitch or slow twitch does not occur until adolescence, when the testosterone increases. So, elementary age, they all can do the long distance or short distance, except our endomorphs, right? They're going to have struggle with it. So children who do poorly in elementary, they might do quite well during or after adolescence, when they might have a higher percentage of slow twitch fibers for aerobic activities, or they might have a higher percentage of fast twitch fibers for team sports that require quickness and strength. So you need to understand at our grade levels from K through 5, their muscle fibers have not done that specialization into fast twitch or slow twitch to 60-40. So we can require them to do both types of activities. Let's look at strength when dealing with motor skills, performing motor skills, and how important it is. When we take strength in relation to the body size, remember, we just talked about the ectomorphs, the skinnies, the endomorphs, the tubbies, they took that word out in this book, and our mesomorphs, the muscles, okay? So, we know that our endomorphs have dead weight, that extra body fat. So the dead weight's going to negatively affect their motor performance. And because of this, it's going to reduce what we call relative strength. Yes, an overweight child may be stronger than a normal weight child for doing, lifting weights, actual weights themselves, but in absolute terms, they are less strong when the strength is adjusted for the body weight. So I want you to know this lack of strength in relation to their body size causes the overweight children to find a strength-related task such as a push-up or a pull-up much more difficult than the task would seem for a normal weight child. So this supports my thoughts on what I was telling you earlier about the endomorphs having such a difficult time in doing push-ups or pull-ups. So what do we need to do? We need to vary or let them personalize their workloads so that they can be successful and they will not hate PE. Let's look at aerobic capacity. I love this saying, children are not little adults. They are not. We can't look at it that way. What is maximal aerobic power? The ability for your body to use oxygen for metabolic purposes. Maximal aerobic power is closely related to what we call lean body mass, more muscles, less fat. And it helps to explain the differences in their performances between boys and girls. When you look at the maximum oxygen uptake and it's adjusted for per kilogram of body weight, there's little chance for boys, no increase, and a little bit of decrease in the girls as they reach maturity. So this decrease in the girls, it may be due to the increased amount of body fat and a decrease in their lean body mass. If you look at 5 adults, 4 out of the 5 adults interested in increasing their endurance athletic performance will actually improve in response to the actual physical training they are receiving. They've had results showing that the training caused little, if any, increase in aerobic power in our prepubescent children. There was a slight improvement sometimes, though, in the running performance, but that becomes more because they mechanically know now, efficient mechanical-wise, on how to run. Another theory is that young children may be active enough that training effects are negligible. What I do want you to know is that's very, very important that you understand. I want you to know that children demonstrate a rapid recovery rate after strenuous exercise. Rapid recovery rate after strenuous exercise. So it doesn't take them as long to recuperate. You and I, we might be breathing heavy a long time, several minutes, but the students, no. The elementary students, no. So what is this telling you about a teacher? I want you to know the exercise bouts of about 30 seconds should be interspersed, should be changed up with some recovery periods of, like in stretching or in non-locomotor movements. And what do we call this? Interval training. I want you to know this, interval training. So you might do 30 seconds, maybe a minute of some type of heavy breathing type of activity, running in place or whatever it may be. And then so stop them and maybe have them stretch or maybe have them do a non-locomotor. Or when you're doing the fitness activities, you're going to need to work upper, middle, and lower body. So break it up to where if you're going to do running in place for the lower body or whatever, if it elevates their heart rate, you might want to mix it up between stretching and some type of non-locomotor movement. So the overweight child, in relation to their physical performance, we know they can't be compared to the leaner child. The overweight child is going to have is going to require a much higher oxygen uptake. The overweight child is going to need more energy just to jog or walk at the same speed as a leaner child, the ectomorph or the mesomorph. The overweight child has less reserve capacity and requires greater exertion to complete the exact same task that a normal weight youth would do or is doing. So we need to adjust the workload. So what do we need to do? I want you to know you should base your student workloads on time rather than distance. Whenever you have your endomorphs in there and you're doing something that's going to require a lot of oxygen. Now, if it's something like arm circles or jumping jacks, no. Okay, things of that nature, you want to do numbers. But if it's something that's going to require oxygen for and you have mesomorphs in your class. I would base it on time. 30 seconds of doing push-ups for third, fourth, or fifth graders as opposed to telling them they need to do 10 push-ups. We should not require children to do the same workload. So I want you to know the intensity of the activity. The intensity of the activity should be secondary to the amount of time the student is performing for some type of moderate activity. Intensity should be secondary. It's all about time. We should do time rather than intensity. Let's look at cognitive growth and development, and in particular the brain. They had some interesting facts here. Did you know the brain weighs about 3 pounds and is 60% fat? Did you know that the brain begins to grow as soon as 3 weeks of pregnancy and continues growing after the child is born? At the age of 6, the brain is approximately 90% of the 6 pounds it will be during adulthood. At the age of 6. During childhood and adolescence, the brain changes structurally. Now, what I thought was interesting on page 30, they talked about the 4 stages. Sensory motor stage from birth to 6. That's where you're learning primarily through the senses and manipulating objects. The pre-operational stage from 2 to 7. That's where the development of memory and imagination occurs. Many students at this age are eager to learn and find joy in pretend play, 2 to 7. Concrete operational from 7 to 11 years old. This is where they begin noticing external events and become aware of the feelings of others, and they start understanding empathy. Then you have your formal operational stage, 11 years and older, where they become logical thinkers, problem solvers, higher level of thinking to learn material and understand concepts better.